Welcome back, students. Let's continue our work on percentages. Percentages come at us in all different places in our lives. Anytime you read a news report, go to Kroger's, watch a sporting event, percentages are used often. Let's see if we can work a couple of good percentage application problems today. Before we do, let's brush up on our skills for changing percents into decimals. I know that if I have a percentage like 84%, the decimal point is there. To change it into a decimal, I always move that decimal point 2 spots to the left, changing 84% into 0.84. If my percentage is 36.7%, and I want to change it into a decimal, the decimal point moves 2 spots to the left, is 0.367. 5% has its decimal point here. Move it 2 spots, and you have room for a 0 between the decimal point and the 5. 5% is the same as 0.05. 3.2%, if I change it into a decimal, also has room for a 0 between the decimal point and the 3. 3.2% is the same as 0.032. 8.5% would look like this. 0.085. If your percentage is 2.09%, you'll use 0.0209. Let's try an application problem. Here's what I'd like you to do. Pause the video and read this problem all the way through once. Then read it all the way through a second time. Then start the video back up and we'll work the problem together. You know, when I work a percentage problem, I have a formula that I use to get myself started. You should write this formula down each time you work a percentage problem. The formula says part is percent of total. That formula will get us through an awful lot of practical percentage problems. All right, let's read the problem through together. The local McDonald's serves an average of 985 customers each day. About 27.5% of these customers use the drive-thru. Find the number of drive-thru customers each day. Let's fill out our formula. I know that is equals. Of is times. 985, that's all the customers, the total number of customers that go through McDonald's each day. Of these 985 customers, 27.5%, that's my percentage, but let's change 27.5% into a decimal, 0.275. The final question says, find the number of drive-thru customers each day. Well, the drive-thru customers, that's not the total number of customers, that's just some of the customers. Now let's use a calculator to get our final answer. We'll multiply 0.275 times 985. 0.275 multiplied by 985. And my calculator gives me an answer of 270.875. That's 270.875 people or customers Let's round that off to the nearest customer. Since this number is large, we'll round this up to 271. It's approximately 271 customers. Now, when you work these problems on your own, write down the formula, fill the formula in, do the multiplication, but then also label your answer. This is 271 what? Well, it's 271 customers. That looks great. Let's try another example. Pause the video and read this problem through once. Then read it through a second time. Then turn the video back on and we'll work it together. Now I know it's a percentage problem, so I've already written down my formula. You should write that formula down each time you start a problem. Let's read the problem through. During an average 40-hour work week, James spends about 6% of his time doing paperwork. How many hours of paperwork does he average each week? Let's try it. Let's fill in the formula. I know is equals, and of is times. During an average 40-hour work week, that's the total hours that he works each week. James spends about 6% of his time doing paperwork. Well, 6%, I should change that into a decimal. That's 0.06. Final question, how many hours of paperwork does he average each week? Well, his paperwork isn't all of his hours. His paperwork is part of his hours. That's what we're looking for. Now let's let a calculator do the work for our final answer. We'll multiply 0.06 times 40. 0.06 times 40 is 2.4. 2.4 what? Well, these are the hours that he averages per week on paperwork. That's 2.4 hours. We'll always label our answers. Here's one last example. Pause the video, read it through twice, and then turn the video back on and we'll work it together. Now I've already written down my formula. Part is percent of total. Let's read through the problem. The Procto company makes 15,250 shirts each month. On average, 2.06% of their shirts are defective. How many defective shirts should they expect each month? Let's fill in the formula. Is equals, of is times. The 15,250 shirts, that's all the shirts they make. That's the total. 2.06% of the shirts are defective, but we should change 2.06% into a decimal. Room for a 0 between the decimal point and the 2, that's 0.0206. How many shirts should they expect each month to be defective? Well, not all of them are defective. Only part of the shirts are defective. All right, now we'll let a calculator do the work. And I'll multiply 0.0206 times 15,250. And my calculator gives me 314.15 shirts. Let's round that off to the nearest shirt. Since that number is small, we'll leave that at 314. That's 314 shirts that are defective. Each problem you work, you should write the formula down, fill in the formula, show your answer, label your answer. All right, your turn. Go try a couple on your own.